This is Unit 2, a continuous sector of the first unit's physical science, and instead of focusing on forces and its interactions, we will be looking at matter and its interactions. And because it is an extension of the first unit of physical science, it will be slightly shorter. To give a brief overview, this unit will include the study of matters, its properties, and its interactions. So starting off with the statement of inquiry again, it states, studying matter and its interactions can provide an understanding of the physical world's functionality. The key concept of this unit will be form, and the related concepts will be interaction, connection, and finally, the global context will be scientific and technical innovation. So, to provide context behind why this is physical science, matter and its interactions relate to the fundamental concepts in physical science, as the branch of science itself handles the material aspects of the world, thus physical. The study of matters and its interactions and properties are one of the basics of physical science, as it can provide a comprehensive beginning of looking more in depth to the natural and physical world and the complexities that lies behind each phenomena. Regardless, here are the unit notes. So starting off with the title itself, matter is defined as anything that occupies space and possesses rest mass. Matter can exist in different states, and it is made out of small particles, which are atoms and molecules. So the states of matter are mainly known in 3 states, and there is somewhat of an anomaly state, but the main are solid, liquid, and gas. So solid is when the particles are tightly packed, and the state of matter has a fixed shape and volume. Liquid is when particles are close together but still can flow. The state of matter has a definite volume, however, it does not have a fixed shape. Finally, gas. Particles are far apart and move freely. The state of matter has neither a definite shape nor volume. And this anomaly state is called plasma, which is a high energy state of matter with ionized or charged particles. So looking into the states of matter, the law of conservation of matter states that matter cannot be created or destroyed. It just changes from one form to another. This basically indicates that matter purely transitions and incites the states in which they exist in. So this is an example. I will be going in more in depth later, but water can be chilled and become ice, but the actual properties of the element cannot change, as it is only the state of matter that has changed. Moving on to the particle theory of matter. The particle theory of matter presents that all matter is made out of particles in constant motion. Temperature affects the speed and the energy of particles. And finally, the arrangement and movement of particles determine the state of matter. So as we briefly talked about it before, every single matter is made out and built in particles, and they are in constant motion, and the only determiner of what state of matter it's in is how fast or how slowly they're able to move. So for an example, liquid, since particles are close but still pretty loose, the particles would be in faster and more active motion compared to a solid, where solid, the particles barely move and are in a compactly built state.